Okay, practice test. This was Monday, April 9th. I just got word from a doctor. I'm coming back Wednesday. So today you're supposed to do a partner and with your notes, homeworks, whatever you have, and see what you know. Tomorrow in class, you're going to have this video, and I want you to check all of this test and know how to do it, because your test is exactly like this, except I just changed numbers around. Write yourself notes, whatever you need. You can use this on your test. So, starting with number 1. It says, first of all, it says approximate solutions to 4 decimal places. I want you guys to know I just got done doing this video, and I didn't record it, so I'm doing it again. So, I'm a little frustrated right now. That's okay. Here we go. So, simplify. Log base 9. A base 9 to the 6th. There's a property out there that says if you have a base 9 and another base 9, they cancel, and your answer is 6. So it's hard to do. But you can also do this on your calculator. You can do alpha window 5. Put a little 9 in here. Put a little 9 in here and raise it to the 6 like that. And press equals. Answer is 6. Older calculators, you would do log 9 to the 6th divided by log 9. 6. Okay. Rewrite this in log form. So when you're writing log form, remember, you want to have it's like, actually I'll just write it over here in the answer column. So you have, it's like a line right here, okay? So below the line is the base of this problem. The base of this problem is 81. That drops below the line, like that. Then it's equal to the exponent. The exponent is 1/2. So the exponent looks small here, but when you write it in log form, the exponent has magical powers and it becomes large, like that. And then the 9 is right next to log. It's not an exponent. It's not 81 to the 9th. It's log 9. So the 9 is the same size as the 1/2 and the log. Do not write the 9 as an exponent or I'll take points off. And that's how you write it in log form. To write something in exponential form, you might want to give yourself the word here. Whenever you're trying to put something in exponential form, you want to swoop. Write the word swoop. So we put the base in there. The base is e. So it's going to be e to the x. E to the x equals 65.98. The only thing that's raised is the x. This is really blurry. Sorry about that. All right, use the change of base formula to do this. You don't have to do this if you have the new calculator. So do log 15 divided by log 5. Log 15 divided by log 5 is 1.6826. 4 decimal places. Okay. For the newer calculators, you just have to press alpha window 5. Put in the 5 here and the 15 here. The same answer. Okay. Gosh, this is so blurry. I'm having trouble here. Use the properties of logarithms to write each expression as a single logarithm. All right, so you have to remember that when you see subtraction, that means to divide. When you see addition in log, this is only with logarithms, you are going to multiply. And when you see a number out front of a log, move it up to an exponent. Those are basically your 3 properties of logarithms. Subtraction means division, addition means multiplication, and a number out front of a log, move it to an exponent. So in this problem, to write this as a single log, first you have to write log base 6, so you have to keep the base that is in the whole problem. So it's base 6 in both of them. So instead of 12 minus 3, you're going to do 12 divided by 3. And what is 12 divided by 3? It's 4, right? So when you write your answer, make sure that 6 is below the line and write a big 4 right here. And that's your answer. So on this one, do you see any numbers out front? I see a number out front right there. This is the only one. That's this one, number out front of a log. So we're going to move this to an exponent. We're going to write a 4 right here. And we're going to get rid of this 4. Once there's no outside numbers, then you could write it as a single log. So what is the base? The base is 2. I do see a subtractions problem, so you will have some division. So as long as there's a plus sign, everything goes on the top. So we have x plus 2, and that's in parentheses, times y to the 4th, because we moved that 4 up to the exponent. No, that minus means we're going to divide by x, and this is your answer. So we'll move that over here, log base 2 of x plus 2, y to the 4th over x. And that's how you write it. Solve each equation. All right, so when you have a single log, your first step is to swoop. So we're going to swoop. 5 to the 3rd equals 3x minus 2. Second step is to add 2. 5 to the 3rd plus 2 equals 3x. Third step is to divide by 3. Fourth step is plug in the calculator. Plug all this in the calculator. So we have 5 raised to the 3rd, right arrow, plus 2. I always press equals next. Divide by 3. 42 point, a lot of 3's. So it's 42.3333. That's your answer. Now on this one, when you don't have any logarithms, you can take the log of each side, or you can change these both to the same base. Like I could change 256 to 16 squared. Do you guys know that? I know that 256 is 16 squared. If you know that, the 16s cancel and x is 2 and you'd be done. Some of you may have wanted to change 16 to 2 to the 4th and change 256 to 2 to the 8th, because that's on that whiteboard up front. If you did this, you could cancel the 2's and you could set 4x equal to 8 and x is 2 that way. Or you can take the log of each side like this, bring the x out front so that we can divide. Once it's out front, then it's a factor, and then we can divide by log 16 to both sides. And x is log 256 divided by log 16. So you just punch in a calculator. Log 256 divided by log 16, which is 2. 2. First page done. All right, let me move the second page out of here. So this one's kind of like that one we just did. You can take the log of both sides, or you can change these both to base 3. Let's try changing these to base 3. So 9 is 3 to the 2nd, and there was already an x, so it's 3 to the 2nd x, equals 3 to the 3rd, and there was already an x plus 3 up there. Cancel the 3's, 2x equals 3x plus 9. Subtract 3x, you get negative x equals 9, and x equals negative 9 if we divide by negative 1. So negative 9 is our answer. So if you go to y equals, you can do these kind of problems on the calculator sometimes. If your answer is reasonable, like if your answer is less than 10, you can check these on your calculator. I would rather check them than just do them on the calculator. But here's 9 to the x, and then here is 27 raised to the x plus 3. And then graph. So what the blue graph that you're seeing is the 9 to the x. The 27 to the x3, I don't know if this is going to read this or not. It's kind of hard to tell where they intersect. It looks like the whole line's an intersection. So I'm not sure if the calculator will work on this one or not, so let's try it. Second trace intersect, number 5, and press enter 3 times. Oh, it read it. It's right there, negative 9. That's your answer. Calculator did it. So in this next one, we have 4 to the x plus 6. Punch that into y1 and punch 9 into y2. Let's try this one on our calculator. 4 raised to the x plus 9, or x plus 6, sorry, x plus 6. And then this one is 9. Let's see if we can do this one in the calculator. You guys got it entered? Crap. This is your first one. That's the 4 to the x plus 6. And then the 9 is a horizontal line. So it's up there at the top, waiting for it. Here it comes. All right, you can see where they intersect. So this calculator should read this very easily. So press second trace, number 5 intersects. 1, 2, 3. The answer is negative 4.4150. Now I'm going to show you guys how to do this one by hand, because some of you would really like to know how to do this, I bet. Maybe not a lot of you, but some of you might want to know how to do this if you're going on to college and maybe have to take a college math course. So anytime you have an x and an exponent, and you cannot write these in the same base. Like I could change this last one the same base, so it's kind of easy, but I can't. 4 is 2 squared and 9 is 3 squared, so they're not the same base. So what you would want to do is take the log of each side. Like that. Then you would want to release your exponent, x plus 6, out front. And then you'd want to divide by log 4. And then you're going to want to subtract 6. So you're going to have log 9 divided by log 4 minus 6. You're going to subtract 6. This is what you're punching in the calculator. So, log 9 parenthesis divided by log 4 parenthesis minus 6. And there's my answer, negative 4.4150. Same one I had. That's just in case you want to know how to do all that work. I personally love doing stuff like this. I bet you there's at least 3 of you in each class that would like to know how to do that. I'm hoping. All right, here we go, 11. I'm going to do 11 like I did 9, changing these to the same base. So this is 2 to the x. 1/8 is really 1 over 2 to the 3rd. And if it's in the bottom as a positive 3, it's in the top as a negative 3. So the 2's cancel and you get x equals negative 3. And that's your answer. Feel free to do that in the calculator right now. You'll get a negative 3. Oh, what the heck. I'll just do it. Some of you are going to try it, so let's just try it. So we have 2 to the x. And then this is 1/8. 1/8 is really close to a horizontal line, really, really close to 0. So what you're seeing right there is 2 to the x. That's exponential. And 1/8 is a horizontal line really close to 0. Again, it's kind of hard to see where they intersect, but the calculator is pretty smart and should pick it up. So we're going to press second trace intersect. 1, 2, 3. Negative 3 right there. Okay, so we're back to solving with some logarithms in it. This is a single log. Write yourself some notes. Single log swoop. So the base is e. So it's e to the 12th equals 3x plus 5. So solving for x, we're going to subtract 5. So it's e to the 12th minus 5 equals 3x. Third step is divide by 3. So this is what you're punching in the calculator. E to the 12th minus 5. Oh crap. Try this again. E to the 12th, right arrow, minus 5 equals divided by 3. Now, do you see how big this answer is? It's 54,249.9305 for 4 decimal places. That's not one you want to know how to do on the calculator. There's no way. you would be able to get that on the calculator. It's just too big of a number, so you will have to know how to do some of these by hand. So for 13, if you have a log on both sides, you can drop the logs, but before you do that, you have to move this 2. So we're going to move 2 to an exponent. So it's going to look like this. Log x squared equals log 36. That's your first step. Now, when you have a log on both sides, you can drop the logs. Just drop them out. They're gone. So you have x squared equals 36. So x equals plus or minus 6 if you take a square root. But we can't take the log of a negative number, so 6 is going to be our only answer that's good. And that's the second page. Okay, third page, 14, we're still solving. We have 2 logs on one side. Anytime you have 2 on one side, you have to condense to a single log. So since there's a plus sign, we're going to be multiplying. Addition means multiply. So we're going to write log base 7 once, and we're going to multiply 3 and x. Our second step is to swoop because you're down to a single log on the left-hand side. So we're going to swoop by taking 7 to the 4th equals 3x. And our last step is to divide by 3. So it's 7 to the 4th equals divided by 3. So it's 800.3333. This next one, we're going to take the natural log of each side, take the ln of each side. Then we're going to release the exponent. Release exponent out front. So keep it in parentheses, 3x minus 9, natural log of e equals natural log of 8. Now you guys should remember, hopefully, that natural log, suppressed natural log of e is just a 1. See that? So when you have a natural log of e, I just usually just ignore it because it's really just a 1. So I just cross it out. So now we have 3x minus 9 equals natural log of 8. So add 9 to both sides. Natural log of 8 plus 9, and then divide by 3. So this is what I want you to punch in your calculator. Natural log of 8, parenthesis, plus 9, press equals, divided by 3, 3.6931. 3.6931. Try it on your calculator. So we had e raised to the 3x minus 9. Older calculators put parentheses because that's a big exponent. Newer calculators, you don't have to. And then there's an 8. Let's see what this looks like. Second trace intersect. 1, 2, 3 is 3.6931 is what I just wrote down right here. All right, so for our 2 graphs, one's a log graph and one's an exponential. Log graphs have vertical asymptotes. And you can tell what it is by looking at the problem. It's this part that's inside the parentheses. So you can set x minus 1 equal to 0, and your vertical asymptote is x equals 1. Okay, and the rest of this we can just get on calculator. So when we punch this in our calculators, you get, we have to press alpha window, 5, log base 2, x minus 1. Okay, and we're going to graph. You should notice that it doesn't go past this vertical asymptote of 1. You guys see right there? Now it looks like the graph stops right here, but it doesn't. It goes all the way down. And we just need some good t-table points. Let's go second graph. See all the errors? We don't want any errors. We want the first order pairs after the error. So 2, 0 is the first point. So I'm just going to write down some t-table points here. We have 2, 0. I see a 3, 1. I see a 5, 2. Let's see if I see any other nice ones. 9, 3. You want at least 3, if not more, points so that you can make this a nice problem. So you have 2, 0. There is it. 2, 0. 3, 1. 5, 2. 6, 7, 8, 9, and 3. Now, as you graph this, make sure you hit all 4 points, and then make sure this comes all the way down, but doesn't touch the vertical asymptote, and put arrows on the end. So your domain is always going to be your vertical asymptote 1 with a parenthesis to positive infinity, because how far left does it go? It goes to the vertical asymptote, but doesn't touch it. That's why there's a parenthesis. And then how far right does it go? And that's infinity. Range is how far down does it go? It goes forever. How far up does it go? Forever. Calculator doesn't look like it's going down forever, but it does. It just gets so close that you can't see it. That's how you do it. So for the next one, this is an exponential graph. It doesn't have a log in it. So this one has a horizontal asymptote. And it's the number that's added or subtracted at the end. So if there's nothing there, if there's nothing added or subtracted, it's just 0. So in this case, it's y equals -2. So this is going to be a horizontal line that it doesn't touch. So everything's going to be above that line. One divided by 2 raised to the x minus 2. Yes, and the reason it's going down instead of growing is because the base is a half. Anytime your base is between 0 and 1, it's a decay. Anytime this is bigger than 1, it goes like this on your graph. It goes like this. It's going down because it has a 1/2 base. So we just need some t-table points to press second graph. Looks like -3, 6, -2, 2, -1, 0, and 0, -1. Those look like the good points. So -3, 6. -2, 2. -1, 0, 0, -1. Now, how far left does this go? Negative infinity. How far right does this go? Positive infinity. So logs and exponential are inverses. So where this one was all real numbers on the range, the domain is all real numbers on the exponential. And then your range is how far low does it go? It goes to the horizontal asymptote, -2. That's the lowest it goes, up to positive infinity. So that's your graph. And 3-word problems, and then we're done. All right, so they actually are giving you the problem, and all you have to do is fill in one thing, which is the T. So one thing you have to fill in. So let's read. The number of acres of cropland rendered unusable by a new weight and infestation is increasing at a rate of 6%. You see how there's a 0.06 right here? They've already got that in, taken care of. If 20 acres are unusable now, that's your starting number of unusable acres. That means there's too many weeds in these acres, so they're unusable for farming because weeds kill plants. How many of these are going to be unusable in 4 years if they keep growing at 6% per year? So there's going to be a lot of wasted land. That's why a lot of farms go under, because they can't get the weed infestation under control. I'm sure in your own yards right now you have weeds growing everywhere. Your parents have to go out there and do weed killer. Just think if you had all these acres of land to do weed killer, it's very expensive. All right, so we have y equals 20 e to 0.06, and we want to know how many acres will be unusable for this farmer in 4 years. It's just straight calculator. Let's press second mode and clear our screen. We're going to go 20e. Raise. Older calculators, you need a parenthesis right now because this is a double number exponent. 0.06 times 4. So 25 0.4 acres are unusable in 4 years. Pretty easy, right? So in this next problem, they give you another formula to use. They want you to use this formula. So it says the average growth rate of the population is this. So your R is 7.5%, but as a decimal, it's 0.075. So it's going to be e to the 0.075 so far. The city's population is now 22,000. That's your P. 22,750 goes out front of the E. What is the expected population in 10 years? That goes up top here. Yeah. So we have 22,750 E raised to 0.075 times 10 for 48,161.75. The Kwans are saving for their daughter's college education if they deposit $12,000 in an account. So that's, and here's your formula right here. So you're starting with $12,000. Let's see. Interest rate is 6.4%, so that's 0.064. Interest compounded monthly. That means you're dividing by 12 here, and there's another 12 here. The end there twice. See it? And then the number of years is 12 years. So there's another 12 in the exponent. So what I like to do is I like to multiply these. 12 and 12 is 144. And use one exponent. This is easier for math, especially for older calculator people. So we have 12,000 parentheses 1 plus 0.064 divided by 12 parentheses raised to the 144th power, because that means your money is compounded 144 times in 12 years. For a 25,812.68. It's dollars. So that is your money. That's how much money you'd have at the end of 12 years. If you started with 12,000, you end up with 25,000. Also, back up to this number 19. Since it was a population number, you probably don't want to say 0.75 people. So some people would round up. Some people would round down. I would accept both of these answers. Actually, I'd accept any one of these three. And that's it.